Hello students, let's resume and let's go over to some recommended problems in 5.2, and I assigned problems 1 through 6. Looks like those are good candidates, and furthermore I don't have to give away any answer here, so let's go ahead with that. Let's go ahead 5.2 and let's see, where is the subsection template? Okay, here, and alright. And then what problem am I talking about? Problem 5 seems okay. We are looking for linear independence for linear dependence. Test for linear. Okay, and then what are those two functions given? Y1 is log of 2t. Let me just log. Our textbook is using ln, but I like log in upper level class. Log of 5t. And of course, inside of the logarithm has to be positive, so we're going to restrict ourselves only to t greater than 0. Okay, let's talk about it. And what is the best way to test for linear independence for two functions? In my opinion, the best way to do that is to check the collinearity, whether one function is constant times another. So let's take the ratio. So log of 5t divided by log of 2t. Is this constant? The answer is no, this is not going to be constant. Let me increase the font a little bit. Why? If you use the log rule, you're going to get log of 5 plus log of t. And then down here, you're going to get log of 2 plus log of t. And then you can divide each by log of t. Then what you're going to get? Wait, you don't really need it. I mean, these two are the same, and then we have two different constants here. So it's clear this is not constant. Yeah, this is not constant. Therefore, or that is linearly independent. Now, what if you want to use Wronskian? Well, I don't require Wronskian, but you could calculate it. Let's see. Wronskian, all right. Determinant of first function, log of 2t. And what is the derivative of this? It's a log function, so 1 over 2t. And then you have to multiply the derivative of the inside. That's it, isn't it? So after simplification, you get this. What about the other function? Log of 5t. And then if you take the derivative of it, 1 over 5t, and by chain rule you have to multiply the derivative of the inside. Simplify, and then you're going to get this. So what's the determinant here? Multiply the principal and then subtract the other diagonal, so 1 over t, and then log of 5t. So what do you get? 1 over t times log of 2t, 2t minus log of 5t. And is this constant? No, it is not. This is log of 2 plus log of t, and I'm subtracting log of 5 plus or minus log of t. So these two cancel out. And then is this constant? I mean, is this 0? Excuse me. For constant, that was for collinearity. For Wronskian, whether it is 0, that's what I'm looking for. It's not 0, isn't it? It's not constantly 0. As a matter of fact, it is never 0. Either way, we have linear independence. If you're not comfortable with Wronskian or determinant computation, don't do this. The first one is much easier. Well, how about some example about linear dependence? I hope I can find some example like that. Number 6, I think. Yeah, this will do. Log of t squared versus log of t to the 5th power. Similar kind of problem here, 2t, t squared, 5t, t to the 5th power. And in that case, do we have linear dependence or independence? Let's check those out. Let's check for collinearity. y2 of t over y1 of t is equal to log of t to the 5th power over log of t to the 2nd power. Let's see, expand the font a little bit. And is this constant? Let's work out a little bit. Let's use log rule. 5 log of t, and then down here 2 log of t if you use the log rule. And what do you have? Log of t cancel each other out. We have 5/2. Oh, that's constant. Which means y2 is constantly equal to 5/2 times y1. They are collinear. Or are linearly dependent. They're collinear. In other words, they're linearly dependent. It's much easier this way. Now, if you want to check the Wronskian, okay, I'm not going to prevent you from doing that. You can do it like this. Okay, first function, log of t squared. And then take the derivative of that, 1 over the inside, and by chain rule, you have to multiply the derivative of the inside. Do you see cancellation? You should. This t and then t squared, one of them cancel out. That's the derivative. Bigger font would have helped. How about log of t to the 5th power? Let's take the derivative. 1 over t to the 5th power, all right. And how about the numerator? By chain rule, you have to multiply the derivative of the inside. That's 5t to the 4th power. Do you have cancellation? This 4th power goes out, and we have only t to the 1st power. So let's go ahead with determinant computation. Multiply the principal diagonal. So we have 5 over t times log of t squared minus, and then the other diagonal, 2 over t times log of 5th power. Is that 0? Well, let's work out the log rule. 2 comes out as coefficients, so we have 5 times 2, 10 over t log of t minus power comes out as coefficient. We have 10 over t times log of t Yes, this is 0. Constantly 0 for no matter what t-value we have. Again, we have same conclusion. They are linearly dependent. If you're comfortable with the derivatives and determinants, Wronskian is good. But which is easier? Well, these two are these two are constant times the other, so they are collinear. That's the easier way to do it.